Okay, in this lecture we will see how to quantify or how to draw this quantitative influence diagram for the moment for a simply supported beam using Muller Breslau Principle. Remember, the first session we have drawn only the qualitative influence line diagram, which shows only the reflected shape and does not show any values. Here we will derive the values. That's why it's called as quantitative influence diagram. See the case here. Here at the point E, we want to draw the ILD for the bending moment at E. So, as the Muller Breslau principle says, at the point E, we have to introduce a hinge. You can show here, you can see here as it is a hinge, and we bend it upward, so it will deflect the shape as shown here. But the one condition is that the relative rotation should be equal to 1. So you can see here, that is, what is meant by relative rotation? That is the rotation theta 1 and theta 2. That is theta 1 plus theta 2 is equal to 1. That is what shown here. Theta 1 plus theta 2 is equal to 1 here. So how to find out these values from this geometry? So see here, E dash, this is what we want to find out. E dash is nothing but AE into tan theta 1, because this angle is theta, this rotation is theta 1, this is theta 2. So applying these properties of triangle, AE tan theta 1 is nothing but AE is nothing but EA, small AE tan theta 1. Similarly, considering this triangle here, EE dash is nothing but is equal to BE into tan theta 2. This is theta 2. BE is nothing but B, that's B tan theta 2. And we know that EE, since both indicates the expression for EE, so we can equate these two. A tan theta 1 is equal to B tan theta 2, and that theta being small, we can write tan theta 1 is equal to theta 1 and tan theta is equal to theta 2 is equal to theta 2. So at last the expression becomes A theta 1 is equal to B theta 2. And as a matter of fact, or the principle of Muller Breslau, the relative rotation theta 1 plus theta 2 should be equal to 1. Substituting the value of theta 1 and theta 2, or substituting the value of theta 1, B by A in theta 2 plus theta 2, this indicates for theta 1 is equal to 1. And at last you will get theta 2 is equal to A by L and theta 1 is equal to B by L. But our point of interest is we want to know how much is EE dash. So EE dash is nothing but A tan theta 1. So A into theta 1, where theta 1 is nothing but B by L. At last you will get A B by L. So EE dash is nothing but, if you remember the previous cases, using the not by Muller Breslau principle, we have derived that we already got AB by L before, if you remember. So to draw ILD for bending moment at E, a fictitious hinge is placed at E and section E is raised by AB by L. The resultant reflected shape gives influence line diagram for ME, moment at E. So let us do 2-3 problems on this so that you will get a good hold on this. See the case, draw ILD for moment at the fixed support for a cantilever beam using Muller Breslau principle. So we need to draw the ILD for the moment at A. So what do we do? So we will remove this restraint and we will apply rotation of 1. So what happens? This will rotate by 1 and it goes like this. Since the rotation is theta is 1, so since and span is also L, so you will get this is also L. This, so that tan theta by 2 or L by L is equal to 1, you will get like this. So what is the meaning of this? What does this shape indicates? Meaning is that when the load is at point B, the bending moment at A is this one, this much L. Similarly, when the load is here, your bending moment at A is this ordinate. When the load is here, your bending moment at here this much, and when the load is here, bending moment is 0. This is what this indicates. Similarly, if you want to draw ILD at the center midspan of a cantilever beam using Muller Breslau principle, what do we do? We will apply at this point, we will apply a fictitious hinge and we will apply unit rotation. So this part is not going to change because since it is being fixed, nothing is going to happen this for the part AC. So only this portion, CB portion, since we introduced a hinge, fictitious hinge, so it will rotate by 1 unit. So this distance BC being L by 2, so this will also become L by 2. So your this figure indicates the ILD for moment at C using Muller Breslau principle. With this, let us conclude this session. Thank you very much.